All right. I'm sorry there was a interruption in the network. So I hope they're getting everything back. That will also take time. Why do I have to verify my address? ये तो बहुत गड़बड़ है. I can simply go to whiteboard. Hear me? No.
Yes, sir.
Okay. So
Yes,
it
sir.
take. I think it takes some time to
Sir,
get.
are you in the campus now?
No, I'm not. I'm at home. Why? Why are you asking this?
So because the campus Wi-Fi keeps stopping like this, it has all kinds of problems.
Acha. No, my Wi-Fi does this only twice a day, and it's not certain when do I. It should come back now.
So which connection is it?
This is Airtel. No, but it's not because of Airtel. It is because you see, we live in a society where there are some 100 odd houses, and if somebody has a power problem and the power has to be switched off, then everybody's power has to be switched off. Or if the BACS does this, वो power खत्म बंद करती है, तो तब भी वही बात है, that power सबका चला जाता है. तो इसका मतलब है उसको रीस्टार्ट करना पड़ता है. रीस्टार्ट करने का मतलब है it'll take time. That is what is happening. That is what happens. Am I good? Where is my whiteboard? I cannot write yet. वो वाला अच्छा था. Do I need to share again?
Yes, sir.
Yes, sir.
Yes, I'll do that. I'll do that. Let's see. Can't share your screen. Sorry, an error has occurred. Which means that the internet has not yet come.
But sir, we are able to see the screen.
Oh, you are able to see the screen. तो इसको मैं dismiss कर दूँ.
No, sir.
Shall I dismiss this? कर दिया. Where is my network? Oh, network has come. So why is it that I'm not able to get the screen? स्क्रीन कहाँ चला जाता है? नीचे होगा ना कहीं पर. इसको हाइड करेंगे तो नीचे आएगा. मीट गूगल नेटवर्क एनालिसिस मीट माइक्रोसॉफ्ट व्हाइट बोर्ड आ गया, मगर आई कैनॉट राइट ऑन दिस येट. ओह यस, मे बी आई कैन. नहीं लिखने दे रहे हैं, अभी उसको टाइम लगेगा. Anyway, so are you convinced with the last steps that we had written, that if it is if yt equal to if yt is equal to beta x alpha t plus beta, then you shift by beta first, and you,
So screen is not visible, so
because it is not allowing me to make it visible.
So you have not shared your screen.
I have.
Sir, I can see it.
yes, he has.
Sir,
We have to.
yes, sir.
Yes, sir.
What do I do?
No, sir. It's fine from your side. He has to pin your screen.
Many of us are not able to see screen, so
So you
you
Okay,
guys
sir.
have to pin
Stop sharing and then try to share again.
the
how do
screen.
I stop sharing? I have to stop. I have to stop the meet then.
No, sir. Yes.
Here.
No, sir, just stop sharing.
Stop
There's an
sharing.
option there on, and then just try to share again.
अभी वो शेयर नहीं करने दे रहा ना, दोबारा से शेयर नहीं करने दे रहा है वो. It'll take a minute. Let me start again. Okay. Let me start Meet again. And now I think I will be able to share my screen and then share. अब हो गया?
Yes, sir.
But I still cannot write on my whiteboard. Where is my old whiteboard? पता ही नहीं क्या हो रहा है. इसमें था ना मेरा whiteboard. कहाँ गया? हिस्ट्री में जाके नहीं तो फिर से हो गया. ये नहीं चाहिए, ये भी नहीं चाहिए. क्या भाई, ये सब प्रॉब्लम्स मजा नहीं आता है. Should go smoothly once the class begins. But have I made myself clear in that? Do you think that the way I have explained, you understand? If you are given a problem of transforming the independent variable, then you'll be able to solve any kind of problem, whether it is change in alpha or change in beta, negative sign, positive sign, whatever. Is that clear now?
Yes, sir.
Right. So
Yes, sir.
if it is not, then I can take some other examples. Whenever I get to my whiteboard, then we can start again for this. Okay. तो अभी क्या करेंगे फिर बोलो. जब तक लिखे नहीं ना सामने, सबके पता नहीं चलता है ना. But we can perhaps talk about this because there are other ways of classifying signals. And whatever I'm going to tell you, you know it very well. So I don't think I need to write something. देखो आ ही रहा है वैसे भी. So I want to talk about, let's say, even odd signals. You know what is an even signal? नहीं, अभी तो हमने वो नहीं किया.
Sir, x of minus t equals x of t.
That is right. अभी हमने discrete time तो किया ही नहीं है इसमें. वो भी तो करना है. But let the screen come, then we'll talk about this. Then we'll tell you कैसे करना है वो सब. आ गया शायद. Yeah, I think I can write now. Yes, I can. ये क्या? यही है हमारा स्क्रीन. ये है नहीं, ये तो कल वाला है. ये नहीं है भाई. आज वाला कहाँ गया? अगर आज वाला नहीं आता है तो we'll start a new screen. Doesn't matter. हाँ, देखें तो क्या करता है ये. Discrete time is important. ये अब आ जाएगा, पुराना वाला इसमें भी आ जाएगा. ये आ गया. कहाँ गया मेरा पुराना वाला? ये है नहीं, ये तो नहीं है. ये
Yes, sir, that one. Yes, sir. S
ये वाला,
and
ये
S.
वाला. हाँ, whiteboard tips बोलेगा ना अभी तो फिर गड़बड़ हो जाती है. आ गया. But where is
So you have to zoom again.
Is it?
So zoom, it's on the bottom.
Yeah, I guess so. I think so.
Yes, sir.
ये बहुत छोटा हो गया. अच्छा, इसको पहले हटाना पड़ेगा ना, तभी तो जूम होगा. ये भी टाइम लगेगा. So have you started thinking about what will happen when you have a discrete time system, discrete time signal, I'm sorry, then it is n, the independent variable is n, which needs to be changed, isn't it? Am I right?
Yes, sir.
अभी क्या करना है, दोबारा से शेयर तो नहीं करना है. कैन यू सी माई स्क्रीन? यस यू कैन.
Yes, sir.
ये जरा हो जाए ना, अच्छा एक्सपैंड हो जाए, जूम हो जाए, तो फिर थोड़ा काम चले. अब शायद हो जाएगा. नहीं हो रहा है भाई. ये बहुत गड़बड़ वाली बात है, इससे तो कुछ नहीं होने वाला. थिकनेस 3, थिकनेस 6 करके देखते हैं. नहीं, वही प्रॉब्लम आ रही है. क्या बोला था, पहले मैं इसको स्विच करूं, फिर मैं इसको, फिर वापस यहाँ पर. इज दैट राइट? सेम प्रॉब्लम दैट इज कमिंग. क्यों हो रहा है ऐसा? एनी सजेशंस?
Sir, it's again zoomed out, sir. As you can see in the bottom,
Yeah,
at
but
the
it's
center, we
It's
can
not
see
zooming
that.
in. It's not zooming in. Huh?
Okay.
I don't know why, but it's not zooming in.
Try refreshing the page.
Huh?
Sir, you're refreshing the page. Sir.
Refresh the page. How do I refresh the page? है कोई जगह रिफ्रेश करने वाली?
Sir, in your browser.
अच्छा. तो no text.
Sir, on the up left, sir.
To the left side of the address bar.
Left side of the address bar. I should have.
Button.
This is the one? Okay. कह तो रहा है कि it's loading board content. ना किया तो नहीं इसने कुछ.
सर अब जूम इन करके देखो.
कर रहा हूँ ना, वही तो कर रहा हूँ. हाँ हो रहा है, कुछ हो रहा है. इतना जूम आउट हो गया. अरे फिर बंद हो गया. क्या बात है. फिर से रिफ्रेश करूं क्या? आई डोंट नो. ये आ ही नहीं रहा है ना, ये रीडू और ये नहीं आ रहे हैं. इसका मतलब है कुछ गड़बड़ है. पहले तो बहुत जल्दी हो जाता है. कुछ हो रहा है भाई. ये तो हो रहा है मगर अब कुछ ठीक हुआ है. We have wasted so much of time because of this. So is this okay? This is okay? Do you need to have another example or something for this? Although we'll have an example when the discrete time signals are taken up. But इसमें कोई problem है तो बता दो भाई. You must understand this because it will come very often that you have to do this, and you must understand it thoroughly. That immediately आना चाहिए कि ये signal मिला है transformation के लिए, तो transformation of the independent variable, then हमें क्या करना है? Immediately पता चल जाना चाहिए, ठीक है? So what should I understand? बोलो. कोई जवाब देगा तो पता चलेगा ना. हमें और सिग्नल.
Yes, sir. It's clear.
Clear? Okay, fine. जोर जोर से बोल रहे थे वो बच्चे कहाँ हैं? क्यों नहीं बोल रहे हैं वो?
Sir, can you scroll up like
Yes, sir, it is clear.
points?
Yes,
sir. Yeah.
I will scroll up. I took two methods. One is this method. The other one is this method. So this method, if I call this as method 1, then this is going according to method 1, and this is going according to method 2. If this is method 2, ठीक है? Shall I say method 1, method 1, method 2, method 2, ऐसे जा रहे हैं, ठीक है? तो the only thing that I wanted to tell you was that there is a definite method of finding out whether you are doing it correctly or not. And what is it? Finding out from the argument of x. Time axis वही है, t है. तो argument of x will tell you whether you are doing correct. For example, what is the argument of t? Argument of t in x. This is x of alpha t plus beta. In our case, an alpha is equal to what? 4. We have taken alpha equal to 4 and beta equal to minus 1. Therefore, at this point, the argument must be 2. So 4t plus or minus, 4t minus 1 should be equal to t, equal to 2, which means that t must be equal to 3 by 4. Which means that this point should shift to 3 by 4, which is what is happening in both our cases. In our cases, okay, we're finally getting the same thing. इसका final answer shift के बाद draw नहीं किया, but it's after shifting you will get this thing only. ठीक है? After shift, right, by what? Beta by alpha, you get this same curve. That is why इसमें करना है तो एक ही point देना है. When other point is here, when 4t minus 1 is equal to minus 1, then in y t is equal to 0, which is this point. From here it goes to this point. So this point goes here and this point goes here. यहाँ पर ये हो रहा है, ठीक है? Either you do it by this method, shift first, and move and compress or expand later, or by this method, compress first and shift later, or you do this argument matching, then you will get the same answer. Okay, you can check your answer whether it's correct or not. ठीक है बच्चों?
Yes, sir.
Is this understood?
Yes, sir.
Yes, sir.
Okay, fine. I am sure it must be understood by now. तो अभी हम इसको कलर चेंज कर देते हैं, ब्लैक ही कर देते हैं, so that we can talk about discrete time signals, transformation of discrete time. Let me write discrete time को dt कर देते हैं, continuous time को zt कर देंगे. Discrete time independent variable. You will give me the answers as to what I am talking about. So in this case, then yn should be equal to alpha x of alpha n plus beta. ऐसे ही तो करना है ना? ठीक है? At this time, we assume that, I'll tell you why. Assume that alpha is equal to 1. All right? Or minus 1. Or minus 1. 1 se chalega. Minus 1 only means shifting. Inverting in time. Okay? So it's not a problem. So इसको अभी छोड़ देते हैं, अभी इसको छोड़ देते हैं. Let's take alpha equal to 1. Then this is equal to x n plus beta, which simply means that you're shifting left or shifting right, isn't it? Depending upon whether beta is positive or negative. ठीक है?
Yes, sir.
Right. So ये तो पता है हमको. अगर मान लो ये सिग्नल है, let me draw a signal. Let me draw an xn, and let's say this xn is like this. It is constant for first 3 samples, and then it goes like this. Next 3 samples it goes down, and let's say 4 samples it goes down, and then it becomes constant again. Till this point, after this it is 0. All samples are 0. Suppose this is xn. Then can you tell me, this is sample number 0, this is sample number 1, this is sample 2, ये सब लिखना पड़ेगा. This is sample 4, this is sample 6, this is sample 7, this is sample 8, this is 9, this is 10, this is 11. Let's say that it is 11 samples, doesn't matter what it is. So suppose that I tell you to plot xn plus 2, what will happen? What will you plot?
Sir, all samples will be shifted left by 2.
That is right.
Yes, sir.
So,
The entire sequence will begin from x equal to -2, then
That
n
is-
equal to -2.
so rather than plotting the whole thing, the graph will remain the same, only it will start at 2. So I'm changing the axis.
Yes, sir, the y-axis.
The new axis for beta equal to 2. Okay, so it will shift by. Then this will become 0, this will become 0, this will become -1, this will become -2. सारा ड्रॉ करने में बहुत टाइम लगेगा, इसलिए मैं नहीं ड्रॉ कर रहा. ठीक है? But if anybody has not understood this, tell me, I can draw the whole thing again. Doesn't matter. किसी को भी अगर ऐसा लगता है कि मुझे दोबारा ड्रॉ करना चाहिए, तो आप मुझे बता दो, कोई फर्क नहीं पड़ता है. थोड़ा सा टाइम लगेगा, But anyway, everybody will understand. Okay. अगर बीटा negative है तो of course you are shifting right. That's okay. That's again same thing. Now, the problem is that in discrete time case, beta has to be an integer number. Do you realize why beta must be an integer number? मान लो बीटा हाफ है तो xn प्लस हाफ क्या होगा? n प्लस हाफ पर तो कोई सैंपल है ही नहीं. Do you understand that?
Yes, sir.
Yes, sir.
Therefore, beta must be. In fact, whatever you do, the argument must be an integer. Well, that is only possible. N is an integer, and therefore beta, to make beta an integer, to make the argument an integer, beta must be an integer, either positive integer or negative integer.
Sir, but this is the case when every variables are in integer form.
That is right. This is the case. That is discrete time signal. Discrete time signal में independent variable is only an integer in terms of an integer.
Okay, so we can't take decimal values.
You cannot take fractional values the way it is described.
Okay,
It is not possible.
okay, sir. Sir, this is the case for whole discrete signal.
Whole मतलब?
I mean, जो भी होंगे discrete signals, उनमें जो सारे n होंगे वो integer ही होंगे.
वो तो हमने आपको बताया ही नहीं. अभी हमने इस सिग्नल के बारे में बताया है when I'm changing beta. Okay, but well, there are exceptions, but we are actually at a very immature level to understand what happens when I do those kind of things. Okay, तो अभी उसको छोड़ देते हैं, अभी उसको नहीं करते. हमको थोड़ा टाइम चाहिए जिससे कि हम समझ सकें कि वो फ्रैक्शन होने का क्या मतलब है. We will do that later. Okay, but we'll do it. We'll do something about it. Okay, we'll not. It's a whole new theory because you see, and this theory, this whole new business of changing this or compressing or even compressing. You see that I cannot compress. I cannot have the independent variable like this. Suppose I write yn equal to x 1 by 2 n plus beta. Can I write it like this? 1 by 2 n, it doesn't exist. So I have, the compression is not defined like this, as in the continuous time case. This is not correct. This is not correct. Incorrect. Because we have samples only at integer values of n.
सर बट अगर n इवन हुआ तो फिर 1 by n by 2 तो फिर सेंस करेगा ना इसमें भी.
n even हो गया तो you are saying that alternate samples are equal to 0. Odd samples, the value of the samples, odd samples is equal to 0. तभी वो कर सकते हैं ना.
ओके, तो सैंपल लॉस हो जाएगा उस केस में.
अगर 0 नहीं है तो फिर वो सैंपल लॉस होगा. You are actually, this is one of the things that is done in any kind of your basic pictures. Can somebody mute his phone? This is the beginning of talking about compression of a discrete time signal or expansion of a discrete time signal, and we will talk about it much later. Okay, at the moment we are not going to talk about it. So only thing that we're talking about is these kind of signals. At the moment, go back to black. At the moment we can do, we understand. I hope we understand. I can say make a statement, understand. Signals of the kind yn equal to x of n plus beta. Beta can be, oh, I'm sorry, ये नहीं लिखना चाहिए ना मुझे, मैं भी मिस्टेक कर जाता हूँ. Square brackets and or yn equal to x of minus n plus beta. ये ठीक है. माइनस एन मुझे पता है क्या करना है, सिर्फ सैंपल्स का साइन चेंज करना है, so that a positive sample, value of the positive sample go to the negative. That is, there is a time reversion. ठीक है, ये मुझे
Yes, sir.
पता है, राइट. सो ये हमको पता है. तो इन दोनों केसेस में क्या करेंगे, पहले हम शिफ्ट करेंगे. इफ बीटा इज पॉजिटिव वी शिफ्ट लेफ्ट, इफ बीटा इज नेगेटिव वी शिफ्ट राइट. वो शिफ्ट करने के बाद तब हम टाइम रिवर्सल करेंगे. पहले हमने देखा ना, हम पहले शिफ्ट करते हैं बाद में रिवर्स करते हैं. क्योंकि अगर रिवर्स कर दिया पहले, अगर इस केस में मान लो कि पहले रिवर्स कर दिया, तब बीटा का वैल्यू भी नेगेटिव हो जाएगा ना, फिर तुमको शिफ्ट जो है दूसरी डायरेक्शन में करना पड़ेगा. आई होप यू अंडरस्टैंड दिस. That is, I can put this as equal to x of minus n minus beta. And now you invert the direction first and then shift in what direction? In the which direction? Bolo.
If beta is positive, right direction.
Beta is positive. Yes.
Positive.
Then right. That is right. That is right. ये अच्छी तरह से समझ में आना चाहिए. All these things are सब तरह का प्रॉब्लम मैंने बता दिया है, क्या क्या हो सकता है. The only thing we are not talking about is compression and expansion of the time axis in this case, or shift by fractional number of samples. वो भी हम नहीं कर रहे हैं, हम नहीं बता रहे, अभी नहीं बता रहे. Maybe later on we can talk about it. We will see if we can talk about this. This is called, what is called a multi-rate signal processing. And a multi-rate signal processing means that I cannot explain to you at this time. I don't know. I will explain it to you later. And there's a whole new big theory about multi-rate signal processing. I'll tell you briefly about this. Let's go back a little to this. ये वाला है ना, x. Come back to this here. X alpha t plus beta. X alpha t. Consider this example. Consider again. Consider again the example of continuous time signal xt yt. I'm sorry. ओह, ये क्या कर दिया मैंने? अरे बाबा, फिर वही गड़बड़ हो जाएगा. ओह, What am I doing? फिर से चला गया वो. I'm sorry, my mistake.
So maybe we could continue in the next class then.
Of course we can. There's no problem. I thought I'll finish this so that in next class we can take up something very interesting. More interesting, that is. ये हो भी नहीं रहा है अभी. We'll talk about it next time.
Sir, try to double click on the screen. Maybe
On
it
the
will-
screen?
on the whiteboard. So try to double click. Yes, and then zoom.
ये वापस जा रहा है. It is doing something, but then it is going back. We will talk about it again. Don't worry. In the next class. You have a class now? Or ECE students have a class now. Is that right? Or all of you are sleepy? I am also sleepy. Don't worry.
So no class right now.
Okay, then you're sleepy or what? Or can we finish this part?
So if the whiteboard is alright, we can fix it. So we can finish it.
Okay, let's see if it takes some, if I can quickly finish this. क्या करें फिर से? ओह, ये कुछ हो गया भाई. कुछ तो हो गया है. But I don't know. What was I talking about? हाँ, okay, ये ऐसे बात भी कर सकते हैं. Don't worry, बात भी कर सकते हैं. Suppose I have a tape recorder, an audio recorder, and I want to play back the audio recorder. That some song I like very much, some music I like very much, and I want to play it back. But it so happens that my player is not tuned to a good frequency at which it was recorded. Suppose that the playback is at a faster rate than the original recording rate. What would you say has happened? The time scale has compressed or it has expanded?
So please repeat the question.
Compressed, so
Compressed.
Compressed.
Shall I repeat the question as somebody said?
yes, sir.
Okay. I have recorded some music on a tape recorder, an audio recorder. But my playback, I'm playing it back on a machine which runs faster than the rate at which it was recorded. So it will look like as if the time has been compressed. Okay? So if it was let's say male voice, I'm sorry, if it was a female voice, then it will be faster than that. Or if it is a male voice, it will be faster than that and it will become a female voice. The female voice is higher frequency, isn't it? I assume that it's higher frequency. Not always, but well, this is one thing. Is that clear? Is that now clear? I've explained the problem again. Now, suppose that the same recording was going faster and suppose that I played back not today but tomorrow. What would you say has happened to the signal? The beta has become negative by 1 day, isn't it? You have shifted it to the next day. Next time is tomorrow. Tomorrow is -1. That is the time at t equal to minus t equal to 1, which corresponds to the next day. A physical example. Is that okay?
Yes, sir.
What I'm saying is that shifting left means that you are delaying the playback. You are starting the playback. Today you are starting the playback at 0. If you play tomorrow, then you're delaying it by 1 day, and therefore you will be starting at t equal to 1, not at t equal to 0. Okay, this is a practical example.
Sir, can you repeat this point, sir?
Okay. Let me take now some other example. That is, let's say that I start a vehicle, something like that, a vehicle. And if I start the vehicle now and go to my office, it will take, let's say, half an hour. It doesn't matter how much time does it take. And if let's call this time at t equal to 0. Today at time t equal to 0, I start from my home and reach my office at t equal to t plus 1 hour. Okay. If I started from my home at t equal to 2 hours, then I would have reached office in 1 hour, that is at t equal to 3. Is that okay? Which means that the whole travel or the signal that I may have recorded during the travel of 1 hour has been shifted by 2 hours. So if I move later, then it is x of t minus 2. Okay. This is the physical significance of the shift in transformation in the variable, in the independent variable. Is that now understood?
Yes, sir.
Right. If you delay something, shift right of a signal corresponds to delay, and shift right of the same signal corresponds to an advance. You are advancing in time or delaying in time. Okay. There are some wonderful things I'll tell you again some other time when we come to let's say things like periodic signals, for example. They're very nice things that you will know. We'll talk about these things. All right, this is what I thought I should tell you today so that I can start with other kinds of classifications of the signal. All right, so now we can all go to sleep and have dreams about signals and systems. Is that okay?
Thank you, sir.
Right.
Thank you, sir.
Right.
Thank you, sir.
See you next time whenever
Thank you, sir.
the class. I don't know if it's an on.
Thank you, sir.
Will it be an offline class next week?
Sir, I think we'll know by the weekend.
Okay, fine.
Yes, sir. We are scheduled to have offline classes from 28th.
Yeah,
That is
okay.
next week.
That is what I'll wait for. Okay, see you then.
Yes, sir. Thank you, sir.
Yeah. Okay.
Thank you, sir.
Thank you. इसको हटा देते हैं.